Thank you everyone for joining us for this HortiQD fourth webinar. Today's webinar title is The Data Bridge, Connecting Farmers and Robot for Smarter Agriculture. So this fourth HortiQD webinar explores how data enables seamless collaboration between farmers and robotic systems, highlighting the technological advances that make smart, automated agriculture possible. And this session will bring together experts from SITIA, RESI, and us from Tinexta Innovation Hub to discuss how field data and also cloud processing and robotic platforms converge to support more efficient, informed, and resilient farming operations. We will be collecting your questions, and we will try to answer them all at the end of the webinar. There will be a separate session at the end of the webinar with your questions. For any other inquiry, please write in the chat. To ask your question, if you look at the bar above, you can see a Q&A section. You can ask your questions there. I will read them all and collect them, okay? If the questions will be too many, I will select the best one and I will ask them to our experts. But trust me, we will try to answer to everyone, okay? So as first speaker today, we have Dr. François-Xavier Rondeau. And François-Xavier Rondeau is an ENSMA engineer, and he has over 25 years of experience in the design and management of test rigs, integrating various actuators, robots, and sensors. And his speech will be about reinventing agriculture with the power of data, robotics, and human insights. So, François, the stage is yours. Thank you.
Okay, thank you all. Let me share my screen, switch off this, just to present the things today. Okay, just a moment, just to activate. Okay.
Yes, so we can see it very well. Thank you.
Yes, perfect. Thank you. So thank you everyone for joining this webinar. Today we are going to explore how data and robotics can work hand in hand with farmers to address the agricultural challenges of today and tomorrow. So my name is François-Xavier Rondeau, and as Claudio said, I'm the test rig department manager from SITIA. SITIA is the company that developed Tractor, an autonomous tractor designed for agriculture. Okay, so first of all, and to begin with, I would like to briefly describe the global context in which agriculture currently operates. This is clearly under pressure and facing major challenges. First of all, the world population continues to grow regularly. We already know the region under pressure in Asia, and we can also anticipate emerging tension in areas such as West Africa. So we know that by 2050, the world population is expected to reach 10 billion people, which means food demand will continue to increase dramatically. And at the same time, the climate change is making agricultural production far more difficult. We all witness multiplication of extreme weather events, floods on one side, long drought period on the other, violent storms, late frost periods, and sometimes huge temperature variation from one week to another. All these phenomena have a direct impact on agricultural production. Society is becoming increasingly aware of these issues, and even people see the degradation of nature and start questioning their own health and the quality of the food they consume. Consumers are therefore becoming more demanding, expecting healthier and higher quality food products. So agriculture faces enormous expectation, but at the same time, the sector is also suffering from a shortage of labor. Being a farmer today is a very demanding job. It often requires working 7 days a week, and the work can be physically exhausting with long and repetitive tasks. As a result, the agriculture sector has more and more difficulties to attract human resources. In the end, the equation is relatively simple to express, but extremely difficult to solve. We need to produce more, to produce better, with fewer resources and under increasingly uncertain environmental conditions. So the question is, how can agriculture meet these challenges? Today, many farmers feel isolated when facing difficult decisions. Should they irrigate while water resources are becoming rare and criticized? Should they apply treatment while society demands on reduction in phytosanitary products? Should they act immediately or wait for a better moment to minimize environmental impact? Well, all this creates a real dilemma, but fortunately, things are changing. Thanks to the introduction of data and robotics into agriculture, the farmers are no longer alone. Sure, we are now entering a new area for agriculture. If we look back at the history of agriculture over the past 12,000 years since its emergence, we can identify several major stages. For centuries, agriculture was entirely manual, supported only by simple tools, powered by human and animal strength. This was agriculture 1.0, which still exists in some part of the world today. Then, about 100 years ago, mechanized agriculture appeared. The arrival of tractors and motorized equipment allowed farmers to cultivate larger areas with less physical effort. And more recently, over the past 30 years, I would say, automated agriculture has progressively developed. A good example is this milk room, where milk collection is now largely automated. And today, we are reaching another turning point, agriculture 4.0, which relies on sensors, data collection, robotics, and intelligent systems. However, an important question remains. How can we integrate this technology without losing human expertise and experience? Automation, yes. Dehumanization, certainly not. Farmers must remain at the center of the agriculture system. And you know why? Because the farmer possesses invaluable know-how, intuition, and field experience. A farmer understands the land in a way that no machine can fully replicate. For instance, a farmer knows that one specific area in the field is more quickly reacts to rainfall than another one, or that south-facing field may still be affected by air flows coming from a nearby valley. This is experience, this is expertise. And so the objective is not to replace humans. On the contrary, the goal is to use the technology wisely in order to unlock the full potential of farmers. And that's true. Robotics and data can free farmers from repetitive tasks. A robot can repeat operation as many times as necessary without fatigue. And meanwhile, data based on measurable facts can significantly reduce uncertainty. And the benefits are not only physical. There is also a major impact on mental workload. When people are constantly under pressure, they may sometimes lose perspective and make decisions without considering the full context. But by delegating repetitive work and data collection to robots, farmer gains more time and mental availability to analyze situation and make better decisions. In a way, we could now speak about augmented agriculture. And that's true that actually robotic systems already exist in our daily life. Take robotic lawn mowers, for example. They automate repetitive and time-consuming tasks. Early models were limited by boundary wires, but modern robots can now create centimeter-accurate maps using RTK GPS, and some can even recognize flowers and obstacles using onboard cameras. We already live alongside robots that use data from multiple sensors. In agriculture, this is the same principles, which applies to intelligent farming equipment. Some machines are already capable of detecting weeds and deciding which action to perform. I mean, they can distinguish between a lettuce crop and a weed, and then mechanically remove the weed or eliminate it using a targeted laser. Drones are another good example. Although drones are often associated today with military application, and the current wars remind us every day, unfortunately, but they also provide more positive and very useful agricultural services. Light drones can spray treatment in accessible areas where tractors cannot operate easily. Of course, autonomous vehicles, such as tractor, you can see on the video now, are also becoming increasingly important. However, a robot alone has limited value. What really matters is the ability to equip it with sensors and collect useful data. We can imagine many different types of sensors for cover a field. The most obvious ones are weather sensors at temperature, of course, humidity, wind, and rainfall. You know, I live in a wine-growing region, and during spring, I would say April and May, vineyards owners are under constant pressure because late frost can destroy young buds. So they really rely on weather data to trigger preventive actions such as fans or heating system. So weather data are really important, but it is not enough. It's not enough to say that. Field localization, wind exposure, terrain characteristics can also be analyzed and optimized using sensors. Safety is also essential for robots because the robot must be capable of detecting obstacles, animals, or people in its path. This is typically done using LiDAR technology. Cameras are also extremely valuable and versatile sensors, and we will see shortly with the HortiQD project for sure. Artificial intelligence is another key component. Artificial intelligence is not a sensor, but it is deeply connected to data processing and will become increasingly important in the years ahead. All this technology belongs to what we call today the Internet of Things, the IoT. In reality, most of us already use, just an example, many people wear smart watches capable of monitoring heart rate, travel distance, general health indicators. In fact, we are surrounded by connected technology. And obviously, all of this requires strong connectivity and high-speed internet access to manage large amounts of data. So, despite all of this technology, farmers remain at the heart of the ecosystem. Sensors are excellent at collecting data. Robots are highly repetitive work, but farmers provide global understanding, adaptability, and field expertise. So once again, the objective is not to replace humans, but to create an efficient collaboration. And this is exactly projects to achieve. For sure, I invite you to visit the website if you haven't already done so. You have the link just there. So in a few words, HortiQD Consortium is developing a technological solution capable of detecting plant disease and parasite at very early stage, even before the human eye can notice them. The goal is to identify the right treatment and the best moment to apply it. The project mainly focuses on, and especially in apple production. It's a truly European collaboration involving experts from Poland, Germany, Italy, and France. And together, we are building the complete technological chain. The system starts with an infrared photo detector. Infrared cameras are often very expensive and may rely on materials which are restricted by European rules. So the challenge is therefore to develop new sensors based on more sustainable and affordable materials. Our team is developing optical filters capable of selecting the appropriate wavelengths within the infrared spectrum. All these technology are then integrated into a smart camera, which also embeds artificial intelligence to perform a first anomaly detection. But in order to inspect an entire field, the camera needs mobility, and this is where the autonomous robot comes into play. The robot carries the camera through the field and transmits the collected data the useful insight for farmers. In the end, farmers can make more informed decisions. And within the HortiQD project, the robotic platform used for this purpose is Tractor. Tractor is an autonomous tractor with several unique characteristics. One of the most important is its hybrid powertrain. The robot is driven by electric motors, while an onboard thermal generator recharges the batteries when needed. That means that tractor can operate 24 hours a day, 7 days a week. Of course, fuel must occasionally be refilled, but this operation is quick and simple directly in the field. Tractor was designed for multiple cultivation. Surely, it is not intended for huge cereal fields requiring massive machinery, but it is perfectly suited for vineyards, market gardening, and horticulture. Another absolutely essential aspect for an autonomous robot is safety. And Tractor integrates several safety technologies. There is some front bumpers capable of detecting collisions, but more important, it uses LiDAR sensors to identify the obstacles, animals, or people before any contact occurs. The working area is also secured using high-precision GPS mapping. And then Tractor also includes 4G and 5G connectivities. This connection allows mission configuration, remote diagnostics, maintenance assistance, and data transmission. And this is very fundamental for the HortiQD project. See now on those videos, the tractor remains above all an agricultural tool designed to with existing farming equipment. Farmers can simply implement onto Tractor 3.h systems. This means that the transition toward autonomy can happen very smoothly. So the Tractor is the carrier for the HortiQD hyperspectral camera, but is not only a carrier. It is also a connected robot that creates a real link between field. Yes.
François, sorry, one thing. We have feedbacks that your voice sometimes fails. So I don't know,
Oh,
probably it's something that concern your connection, but we can hear, let's say, the 80% of what you say. So
oh, sorry for the
if you
bad
want,
connection.
if I hear that some sentence goes missing, I will tell you so you can repeat it, okay?
Okay, sorry for the disconnection, but I cannot improve this properly. So
No, don't worry,
let's go
don't
like
worry.
this.
Let's go on. Let's
Okay,
go on. Please continue.
okay, okay. Sorry for that. So I was just saying that the robot creates a link between the crops and the farmer. This connection is made possible in particular through the Android application developed within the Twitter ecosystem. Field positioning data and mission parameter are therefore directly available on smartphones or tablets through the platform's Bluetooth, Wi-Fi, and 4G, 5G connectivity. Well, it was a very quick and brief introduction to the main features of tractors, but perhaps the best way to understand its value is through a real user feedback. And today we are pleased to welcome Mrs. Diana Nacouzi from the French Interprofessional Center for Fruits and Vegetables. And Diana will explain how tractor and data collection contribute to research activities and support horticultural producer. So Diana, can you please take the lead to present your company?
Yes, thank you, François-Xavier. Hello, everyone.
Okay.
So my name is Diana Nacouzi, and I'm a research engineer at the SITIA. It's a French technical interprofessional center for applied research on fresh fruits and vegetables. So it's a reference in innovative applied research for the fresh fruits and vegetable sector. We are based in France. We have different centers, and I am based in Languedoc. It's the southern part of the country, between Bordeaux and Bergerac. So the main thematic areas that we work on are, and the main areas of expertise include plant material, plant health and biocontrol, agroecology and cropping systems, greenhouses, product quality and measurements and post-harvest, technical itineraries and marketing, and points of sale research. So I work at the MATIC unit. Can you please go to the next slide, François-Xavier?
Yes, for sure.
And so in my unit, we work on different projects related to technologies, agriculture innovations, sensors, captors, and agriculture robotics. We have an experimental farm of around 70 hectares where we work on different research projects related mainly to agro-equipments, conventional or innovative. We work on prototyping machines, on testing benches. So we have a platform of 1,000 square meters where we can test indoors under controlled conditions and outdoors under real farm conditions, all the agro-equipment that we are used. And we have other colleagues also that work on laboratories like in the molecular biology, virology, fertilization. And the main species in the area include apples, pears, nuts, plums, strawberries, onions, carrots, and lettuce. So can you please go to the next slide? We are working as partners in the GOOD project, which is a European project entitled Agroecology for Weeds, and we are partners in task 5.2 related to weed management through the combination of digital tools and agroecological innovations. So we have in the center the French special pilot where we carry out field experiments in apple orchards. And the experiment started in 2024, and so this is the last year. In 2026, we will finish the last experimental season. The main objective is to evaluate the performance of agricultural robots and suggest alternative solutions to herbicide use. We believe that autonomous agricultural technologies and robots have different advantages for the production sectors by starting by increasing the competitiveness of these production systems, by suggesting alternative solutions to herbicides, and also by suggesting alternatives to or solutions to tackle the labor shortage issues, and especially to reduce the physical burden of some agricultural activities. So we use Tractor mainly as a platform to carry out tools that can help us in weeding the orchard. In this picture, you can see an example of intercept tools that are mounted into the robot. And this can help us to, let's say, suggest new technological solutions to manage weeds in the row, because this is the main problem and the main issue faced by producers. So using Tractor is interesting for us because it has an autonomous navigation system. So the farmer can be working different activities while supervising the robot, let's say, in an orchard which is just next to where he is working. And all the system, time management, the navigation, the GPS are very important to reduce the number of, let's say, rounds or passages that the farmer can, at the end, have benefits or positive impact on the economical, let's say, calculations or impact after a production season. So during this experiment, we evaluate all the technical performance, agronomic performance, the operations in the orchards, the capability of the robot to perform its designed or the activities required in different orchard conditions or soil conditions or meteorological conditions. And then we compare it to conventional, let's say, chemical or mechanical activities to have a bigger picture, feedback, and the real agronomical benefit from using it. So that's it from my side.
Okay. Many thanks, Diana, for your sharing your experience. That's really interesting.
Thank you.
Okay. Now let me reconnect the discussion maybe with the HortiQD project itself. So just to sum up, Tractor moves through the field carrying an hyperspectral camera. Images are captured at different locations, and some leaves or fruits may appear damaged. A first layer on board, artificial intelligence identifies suspicious area. The images are preliminary interpretation are then transmitted to Tractor, which enriches them with additional information such as GPS position, and what about weather condition, and in the future many more sensors may be integrated. And all these data are then sent to the cloud, where intelligent software tools perform large-scale analysis and generate statistics or recommendation. But Stefano will explain this part in greater detail in a few minutes. Okay. So naturally, the benefits of such a solution are numerous. First of all, the data collected are more precise, more abundant, and fully traceable both in space and over time. As a result, information and analysis can be rationalized much more effectively. And on this basis, decisions become more informed, more objective, and data-driven. Consequently, growers can more easily select targeted treatment, applying the right quantity in the right place at the right moment. There is, of course, a significant economical benefit in this approach with less consumed product, but above all, there is a major environmental benefit. That being said, this does not mean everything is perfect. These technologies still face several challenges and limitations. Significant investments are still required to continue development efforts and drive further innovation. In addition, robots and artificial intelligence often generate reaction of mistrust. And regarding artificial intelligence in particular, we clearly feel that society is both fascinated by the technology and concerned about its impact. You see, these are truly key questions of our time. Fortunately, there are ways to overcome this limitation. Education and training are obviously essential. And in some way, this webinar is already part of that process. There is also strong support from major stakeholders in the sector, such as research center as SITIA from the French company described by Diana a few minutes ago. And those centers help the democratization of this innovative solution. Clearly, the future will be built on collaboration between humans and robots, with humans remaining firmly in control of this complex system. Well, HortiQD project is a very concrete example of efficient collaboration between humans and robots. Robotics is not here to replace farmers, but here to amplify capabilities. Similarly, cameras and artificial intelligence are not meant to make decisions instead of farmers. They are powerful tools designed to support decision-making. Farmers are therefore remain fully in control, but now with access to high-value technological tools. In other words, we are moving from automated agriculture towards augmented agriculture. And this evolution already provides several answers to current agriculture challenges. I remind at the beginning of this presentation. First, autonomous robots can help address labor shortage by handling repetitive tasks. Second, farmers gain more time to step back and develop a broader understanding of their operations. Third, agricultural intervention becomes more targeted, reducing the use of chemical inputs. These directly respond to societal expectations regarding food quality and environmental protection. And at the same time, this augmented agriculture becomes capable of producing both more and better. This is the reason why the bridging human expertise in autonomous system is a real answer to actual challenges. Well, thank you for your attention. I will now give the lead to Stefano for the second part of this webinar, and I will be happy to answer your question at the end. Thank you
very much, François. So, Stefano, if you can share your screen, we could proceed with your presentation. So, Stefano Paolini is a pre-sale engineer at RESI Informatica, and he is graduated in solid-state electronic engineering, and he has built his career across pre-sales, consultancy, solution design, and product marketing roles. So today we will tell us more about the data platform for smart farming, increasing value of sensors data through correlation and analysis. So please, Stefano, the stage is yours.
Thank you. Please let me know if there is something wrong with the audio. Again, I will try to switch connection. Thank you to Francois for his excellent speech and for putting everything in context, in perspective. My speech will be focused on how data collected on the field and the analysis of this data is the key to achieve an effective robotics human interaction in agriculture, and how to make robotics usage of robotics in robots in agriculture more efficient. I will cover a few points about data collection, transmission, how field data will be used to assist the farmers in decision making, what are the challenges we faced in HortiQD projects, and what are the economical benefits of these new technologies that we are going to see today, and what are the current market trends that are associated with these technologies. So about the field data collection, Francois already gave a list of what can be collected and as data on the field. We can broadly classify the data in two classes, the data about the environment and the data about the plants. The data about the environment, as Francois already said, usually is temperature, humidity, salinity, rainfall quantity, wind speed, solar radiation intensity, and chemicals. And all of this information let the farmer know about the environment where the plants are growing and how the environment can affect the growth of the plant and the crop. And such data is usually collected by stationary sensor networks such as weather station. One example is shown here in the left bottom corner. And then we have the data about the plant themselves that are usually collected as images or temperature or moisture measurements. The images can be collected in visible light and therefore will provide a representation of what the robot is seeing on the field, or as infrared images or images in other parts of the spectrum that we cannot visualize. And usually, if we want to have an overall view of what is happening on the orchard, aerial drones can be used to collect wider images, while ground robots can be used to have more detailed images of crops and plants themselves. In order to have a better understanding of what is happening, an accurate selection of the spectra that is going to be used to collect the images must be made, and therefore a biologist or an expert intervention, let's see, consultancy, is needed in order to understand what is the better spectrum to be used to understand what is happening in the orchard. All of this information is collected by the robots on the fields and must be transmitted to a computer or a cloud infrastructure to be analyzed. So what are the transmission technologies available today? I come from multiple companies working in telecommunication, and I have to say that we have a wide range of telecommunication means to be used today. We can think about short range and long range communication options. The short range varies from Bluetooth low emission, LoRaWAN, Wi-Fi, and we can also use long range communication, for example, 4G or 5G mobile connections. Usually, the short range communication protocols or technologies can be used to provide access to the sensors from mobile devices carried by the farmers on the field or by devices or moving robots, like the tractor, for example, that could talk via Bluetooth with the sensors on the field directly. If the field is not very large or there is an infrastructure, Wi-Fi infrastructure already deployed, the sensor network could be connected with a local server via Wi-Fi. And also the tractor the robot could take a benefit of the Wi-Fi connection, but usually in the fields the robots are connected via mobile network to cloud services or cloud servers. As I will say it, I will say it later, but in HortiQD we provided also a mean to store the data locally on the robot on an SD memory card that can be moved and inserted into a local server in the case that the mobile connection is not always available. When the data is then transmitted to the cloud, how can it be used? Usually, why the robots do need more data to perform better? Because in the agricultural field, robots do not face a stable environment like in an industrial setting. Within an industry, within a factory, the robots have their lanes, they know where the things are. Usually the environment is stable. Things do not move, light do not change. In the fields, in orchards, there are unpredictable situations. It may be raining, it may be sunny. The sun could be facing the cameras. There could be some obstacles in the path of the robots. So the usage of the field data makes the collaboration more effective. If the robot is autonomous, the field data is used to set the robot targets in advance and to help in navigation. If the robot is remote controlled, the data is needed in order to provide visions to the operator and to provide context awareness to the robot itself. If the robot is semi-autonomous, still data is needed in order to provide context to the robot in order to plan some autonomous actions and for the farmer to approve them. So some techniques and data are listed here that are very useful to the agriculture, to this use case. LiDAR, that is laser images which detect obstacles, RGB cameras, images, GPS data can be used, can be processed with data fusion algorithms, and can improve navigation accuracies of the autonomous robots. Processing images can be used to distinguish between crops and weeds in order to proceed to selective removal of weeds, a case which was already named by Francois. Advanced computer vision can also help robots picking fruits. There are some robots which are being tested with soft grasping tools with the hands that can pick fruits without damaging it. So they needed advanced computer vision, the vision with a depth so that they can understand where to go with the hand and pick the fruit. While we can use multispectral cameras, that is cameras with infrared sensor of different wavelengths, to identify early signs of problems with the growth of the plant or diseases or pest infestation. Other data can be used in order to optimize the use of fertilizers, irrigation, and to evaluate historical trends in crop yields, so to optimize the seed depth and the plant spacing. We can collect a lot of data from the fields. and multiple analysis methods can be used. We can perform statistical analysis to understand what has happened in the past. We can correlate data and try to understand if there is a cause effect between two sets of data that we are looking at. For example, the irrigation, the quantity of water we are giving the plants with the growth speed. We can look at the topological distribution of several parameters in order to understand what part of the soil, for example, retain the more moisture and what part of the orchard retain the least. We can try to understand patterns in data and use artificial intelligence tools in order to classify or cluster data. All of these tools, in one way or another, can help to identify hidden trends into the data, something which humans cannot identify, because when the data is too much, we are just not able to understand all of the meaning inside the data. We can try to get some early warning about diseases or pest outbreaks in order to tackle them in advance or in a very early stage. We try to understand what is influencing the crop yield or quality to get better fruit, larger quantities of crop. And we can also try to understand what is the best crop to grow based on past statistics. Maybe some tomatoes grow better in one orchard, in one field, and zucchini not the same. So if we need to make a choice between two types of plantation to perform in 1 year, we can try to understand it starting from the data. And we can, and also the statistical forecast for the season, the amount of rainfall, the onset of some specific disease can help the farmer, as Francois said before, to manage the unpredictability of the illness of the plants and the weather changement. So based on all of the data that we collected, the farmer can consider different possible actions: treat all of the plants or some of them against diseases, increase or decrease the amount of water, change the irrigation schedule, change the pattern of the harvesting of the fruit, increase the frequency of monitoring, for example, proceed to remove weeds. So a lot of actions can be decided or changed based on the analysis of the data that comes from the field. All of these, this speech is based on the experience that RESI is making, contributing to HortiQD project. As already Francois explained, the project aims to develop a new system to detect some, in this case, in this phase, some specific illness on the plants. And the tractor goes around the orchard, collects images in infrared spectrum of the trees and the leaves, and these images are then processed by an AI module, an artificial intelligence model that is trained to detect the early signs of fire blight and apple scabs, and provides some information like, on this leaf there is a high probability that the infection is coming. What is RESI doing in this project is collecting the data from the newly developed shortwave infrared sensor, which is used to collect the images, collects the data from the GPS and RGB camera, which are on the tractor, and collects the information from the AI model, which says where the infection is. All of this information is then harmonized, that is stored in the cloud data center in a specific format, which makes more easier the correlation between different parameters and the research of different data. and others can be displayed in tables or maps or charts across space and time to the users. The system is also able to provide an input to a decision support system, that is a software which goes through a tree of questions and answers and provide the farmer a support to take some decision. Faced with some situation, this decision support system provides some possible answers. Then the farmers decides which one to select. HortiQD project is depicted on the right side. This is, we already said, how the information is flowing from the tractor to the artificial intelligence module, then through the internet to the server. In the cloud server is also able to connect to some external data sources, like, for example, weather forecast, historical data, or other data which are present already in the farm, and then can store it, correlate it, and present it to the farmer. What are the challenges we are facing in the project? Because not everything is simple. Otherwise, we will not be working here. First of all, the AI model must be trained. And in order to be trained, the training means that the AI module must see what looks like, what an infected leaves or trees looks like. So we need to go and take photos or images in infrared of infected trees, and the infections always spread with the times of Mother Nature, so we are not influence the life cycle of the viruses of microbes, and so we have to wait for the symptoms of the illness to appear also in the samples of that we are going to use to train the AI model, and this introduces some waiting periods within the project, some latency. Then there is the accessibility in terms of connection. The wireless connection, mobile connection is not always available on the field. So we developed, as I already said, an offline upload method to collect data on the tractor and then upload it in a later phase to the server. We need to have to consider that different systems have different interfaces. Therefore, we needed to standardize, to provide a standardization standard format, and to exchange data between different systems of the project, and also between different systems between the server and other systems which are going to talk to the system. And in order to talk also to external system, we introduced a flexibility degree inside the central software platform. So we can develop and put in place different connectors, different interfaces towards different systems to collect multiple data. The more data we have, the more rich the information, the wider the picture that we can have about what is going on in the field. And also we need different algorithms and tools to analyze the data. So the software was designed as modular so that we can add different tools at different times to analyze the data. And last but not least, we need a meaningful correlation. That is, the images coming from the tractor and the data coming from other sources in order to be correlated and in order to be useful, need some tagging, they need some additional information, which is the GPS positioning timestamp in order to be correlated, so that we know where each measurement has been taken and when. Francois already spoke about the benefits of robotics adoption in agriculture. And he already said that robots are useful in order to perform dull, dirty, and dangerous tasks. All of these tasks that are extremely repetitive and low value for humans can be performed by robots without tiring themselves. The robot keeps on until the battery is charged. But the ability of the robot to perform continuously some task needs to be complemented by the adaptability, the flexibility, and the judgment of the farmer, who knows the farm better than anyone else, who knows the soil and has an expertise which is hardly repeatable into an artificial mind or a robot. So the collaboration between human and robots provides to the humans the ability to perform lots of work in the same time, and provides to the robot the knowledge which is lacking. So the key benefits are the saving time for the human personnel, the ability to go through large volumes of data, and also to go through vast areas and to understand where an intervention is required in a very large field in a small amount of time. The ability to look at the data and understand situation through time, in order to understand what patterns are repeating through times, and to understand if something is different or something is similar across two different seasons. The benefit of avoiding exposing humans to dangerous situations, for example, when spraying pesticides, and optimizing the quantity of chemicals and the quantity of water needed in order to grow the crops. The robotics adoption in green agriculture is also something which has a market value, and the market for the robots in agriculture is being pushed on one side by market drivers, and is limited on the other side by constraints. The market drivers are also from the European community, the farm to fork strategy, for example. There are also some policy from the European community which require the farmers to use digital records in order to prove that they are compliant with some ecological legislation scheme. So this means that the farmers are forced to collect digital records and digital data, and collecting this data without using them is, of course, something which is not efficient. Then there is the rise in fertilizer prices, which are unfortunately rising still more due to the Hormuz crisis, which is not still solved. And this year, there are already the news on the newspapers that the fertilizer loads from the ships will come late. And so it's well understood that the farmers would like to get the possible, use the minimum quantity of fertilizer and chemical products and get the maximum amount of yield from their fields. And then there is the labor shortage, which already was pinpointed by Francois. The numbers of employees in agriculture is very low with respect to what it's needed. So the workers in the fields need some help in order to perform their duties. What are the challenges that the robots makers are facing to enter into the agricultural market? The first point is that multiple vendors have multiple software platforms and proprietary hardware platforms. So a standardization process is needed to develop standard interfaces and to make more software and more robots interoperable between each other. Also because the initial investment in robots, it's high. There is a cost which must be borne. And since the large part of farmers in Europe are small-scale farmers, this means that any investment has a huge impact on the tech price. And last but not least, there is a problem with connectivity to the cloud. In some places, there is no connection, no mobile connection. So different forms of connectivity to data sources and data analysis tool on the cloud must be found. Last consideration is that the market trend in any case is positive. The multiple analysts are pointing to a growth of 12% of the market in the next 6 years, between 2025 and 2031, also the global level and at the European level. Precision farming is the farming assisted by data and robots is actually what we were talking about since now. And the final value, predicted value of this market by 2031 is more than $4 million. So it's something billion dollars, sorry. So something very interesting. The European Union is pushing towards the adoption of robotics technology. So this is something that still provides a proof for it's something that is driving the market expansions, and the companies, both large ones like CNH Industrial and startups, are responding to these driving forces, developing flexible products, flexible tractors that can be used for multiple tasks when equipped with multiple tools. So there is the hope that the HortiQD project will leave as an heritage a very interesting tool, a very useful tool that can be mounted on an autonomous robot, can be brought on the field to monitor the health status of the crops and provide the means to optimize the pesticide use and the treatment, the advanced treatment of illness in the orchard. On my side, this is all. And thank you for your attention.
All right. Thank you, Stefano, for your interesting speech. So let's check if there is some question. At the moment, not. There are no questions, so we will wait 5 minutes. In the meantime, I want to tell to the whole audience that I want to remind them that this webinar is recorded and that we will share the recording in the coming days. So you will find it on our website, on HortiQD website, and on our social media. And the other thing I want to tell to our attendees today is that they will receive a short feedback form to share their opinion on today's webinar, so that we can improve actually. And if you want to participate in the next HortiQD events, which will be quite interesting because we will have also a school for PhDs and young students soon enough. So keep following us, keep following our social media and our website, because interesting things are ahead. And so if there are no questions, and I see no questions, we may finish here our webinar of today. I want to personally thank François Xavier for being with us, Stefano, and also Diana Nacusi for her participation. And so thanks to everyone, and stay tuned because there's more to come. Thank you.